In today's video, I'm going to explain the difference between distance and displacement. Most of you are familiar with the word distance, so what do you think of when I mention the word distance? Personally, I think of how far something has traveled. So let's say the distance between this city and the other one is 100 miles. So I know that I need to travel for 100 miles to arrive from this point to this destination. On the other hand, displacement is quite as similar as distance. But the only difference is that displacement encompasses direction. Direction is very crucial when talking about displacement. So let's just say an example. We have a person, let's call him Alex. Alex traveled 9 meters east, and then he turns around and travels 4 meters to the west. So the total distance covered by Alex during this trip is 13 meters, or 9 plus 4. However, this displacement cannot be 13, but rather the displacement will be the difference between the 2 points, which is 5 meters. So let's say we have a number line, and this is position 0, and Alex traveled for 9 meters to the east, which is positive 9 meters, and then he turns around to travel 4 meters to the west, which is negative 4. The displacement is negative 4 meters. So is now his current position is at 5 meters. So his net displacement is 5 meters to the east. So basically we can just say that displacement equals the final position minus the initial position. The final position is 5 and the initial position is 0. So the answer is positive 5. So Alex traveled from point A to point B, which is 5, in 5 units or 5 meters to the east, which is the positive side. So the answer is positive 5 meters. Okay, so in this questions, it says a student walks 4 kilometers north, then 3 kilometers east, and finally 4 kilometers to the south. So we have to draw this before calculating anything. So he walks 4 kilometers to the north, then 3 kilometers to the east, and finally 4 kilometers to the south. And he needs to find distance traveled by the student. So as we said, the distance is the total distance covered during the trip. So the distance equals the sum of all of these, which is 4 plus 3 plus 4 equals 11 kilometers. For the second part, it needs the displacement of the student from their starting point. So it needs a displacement between this and this. Yeah, this part. Since this is a rectangle, this side equals to this side, then this side will be equal to this side, meaning that the displacement equals 3 kilometers to the east. Since it's starting from here and going toward this direction, and it ends here. So it's 3 kilometers to the east. Okay, so moving to the next question is pretty much similar to the one before it. So 4 kilometers to the north, 4 kilometers, and then um, 3 kilometers. Oh, that's too long. 3 kilometers to the east. So we know how to get the distance. So distance equals the sum of these two sides, which is 4 plus 3 equals 7 kilometers. You don't need to mention any direction since this is distance. It's a scalar quantity. It's not um, like it doesn't encompass any directions. But for the next thing, the next requirement, which is this displacement, which is the distance between the initial and final position. It started from here and ends here. So we need this distance. So how do we get this distance? Okay, so as you might notice, we have a 90 degrees angle right here. So we can, and we have two sides, this one and this one. So we can use the Pythagorean theorem to get this side. So let's call this A, B, and C. So as you know, C squared equal A squared plus B squared. So the required side here, which is C2, CC squared, I mean, and see, 4 squared plus 3 squared equals C squared, 16. 3 squared is 9 equals C squared, 25 equals C squared. We take square root for both sides, then C equals 5 kilometers. So AC is 4 kilometers. So the displacement is 4 kilometers in the AC direction. This direction is AC. Okay, so in this question, it says an object moves along the grid through points A, B, C, D, and F, and the side of square tile measures zero point 0.5 kilometers. So one tile is 0.5 kilometers. It needs us to calculate the distance covered by moving the object from A to F and the magnitude of the displacement of the object. So starting by the distance. If you know that one tile equals 0.5 kilometers, let's just count the number of the tiles we have till we reach to the final position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 tiles multiplied by the length of one tile, 0.5. The answer is 6.5 kilometers. So this is the distance. Okay, now for the displacement. How to get the displacement? Okay, so for the displacement, um, it needs a displacement from the initial point, which is A, to the final point, which is F. So let's just connect these 2 points and just draw a projection right here. And apparently, this reminds us of the Pythagorean theorem. We can just use it. If you know that the length of one tile is zero point 0.5, then 1, 2, 3, 4, then 4 times zero point 0.5 equals 2. And this 1, 2, 3 tiles multiplied by the length of one tile equals 1.5. So by using the Pythagorean theorem now, let's see. So AF equals 2 squared plus 1.5 squared. So let's calculate this. 2 squared plus 1.5 squared equals 2.5 kilometers to the AF direction.